So I picked a very simple alkene for my demonstration here. This would be 2,3-dimethyl-2-butene. And I've chosen a very symmetrical, very simple alkene so that we can focus on the details of the mechanism. And in another video we'll take a look at what happens when we have more complex alkenes. Now I'm going to halogenate my alkene using molecular bromine. And you may immediately stop and say, wait a second, Davis, you're telling me that the pi electrons from an alkene are going to attack a molecule that's nonpolar, doesn't even have a dipole. How could it have an electrophilic site? And you'd be correct. But it's going to attack because the bromine atoms are very large. They have big electron clouds that are very polarizable, very squishy, and easily pushed around. And so we can induce a dipole by attacking it with the alkene. And that's exactly what's going to happen. So let's do that now. So when the alkene attacks, as you might expect, we generate a halide ion. But what you may not expect is that we don't generate a carbocation as I've shown you here. Instead, we generate something called a cyclic halonium ion, in which the halogen, or bromine here, sits atop the carbon-carbon bond and sort of distributes its bonding electrons among the three atoms in a cyclic structure like I've shown you here. And the most important side effect of this is that our newly generated nucleophile, the bromide ion, cannot attack my cyclic bromonium ion from the same side because of the steric obstruction from the bromine that's already there. Instead, in order for my nucleophile to attack, it's going to have to make its way around to the opposite side of the molecule and attack from that side. And when it does this, I'll get my new carbon-bromine bond, and I'll break that cycle of the bromonium ion to create something called a vicinal dihalide. So what's important about this mechanism is that my bromines have attacked from opposite sides of the molecule in what we would call an anti-addition. And although it may not seem important to you now because of the simple symmetrical alkene that I chose, you can imagine that as things begin to get more complicated, that regiospecificity and stereospecificity will start to come into play. And we'll talk some more about that another time. That's all for now. I'll see you.